Hi everyone, in this video I would like to show you how to create a system that realizes this logic expression. So your output y is equal to a and b. So if both of your a and b are true, then your y is going to be true. Okay? And this is the schematic of how you are going to realize this. Actually, this is, as you may know, it's a simplified version of what I presented in the first video for lab 10, I think. Yeah. So here's a slide switch for A, and here's another switch for B, and those are being connected to LEDs so that when you turn it on, power 5 volt is going to be connected to this LED and it lights up. So these two are just the indicator to show whether A or B are on or off, okay? And these are the vertical lines that I generally use for input streaming, right? So this is for B and this is for A. So B and A are being connected using an AND operator. And this chip 74HC08, this corresponds to an AND chip. And then the output of that AND chip is going to a LED through a resistor to the ground. And you want to provide a 5 volt input signal from either from a battery, but we have our Arduino board, so we are going to use this to create a 5 volt input, okay? However, the point here is we are not using any coding at all, okay? So there's no coding, no like active control of this thing. Once you just create the circuit, it's all just done. It's a passive thing. Okay, so let's take a look here. This is actually the circuit that I created. So you may want to take a look. And Arduino board, I just use this to drag and drop. Well, it's a little bit sluggish. Yeah, okay, go away. It's fine. So you can use this guy to have it there. And let's check all, and from here you will be able to scroll down to find, okay, the slide switches and the LEDs, and the logic gates are actually down. These are op amps. Yeah, it's down here. So we have AND, NAND, NOR, AND, OR, exclusive OR, inverter, etc., etc., etc. Okay, so I just pulled up this AND gate 74HC08 and then located here. So this is these IC chips. It's like similar to op amps. You need to put it in the center of these two areas so that each legs are being connected to individual lines. Okay, so this is your AND gate, and this is the switch for, let's see, this is for A. A is blue, B is purple. So A is blue, this is for your A, and this guy, well, it was purple, red, it's similar. So this switch is your B, okay? Fortunately, if I wish I could write down on the screen, but fortunately I don't have that ability here. So, and you see this Arduino board, I'm only using the ground and the 5 volt. I'm not using any of these input or output pins at all. Okay, so this Arduino board is just utilized for a voltage source. Okay, so ground is connected to ground and 5 volt is connected to 5 volts. So if we just take a look at this switch, your signal is being connected to one leg and ground is being connected to the other leg, and the common node is being used for signal depending on whether you slide it to the left hand side or the right hand side. So the signal is connected to a resistor and to a LED, LED, again, they have polarity, so you need to make sure the long one is connected to the signal and the short one is connected to the ground. So it goes to the ground, 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 and the black wire goes to your ground. Again, I'm not using any of these input or output nodes. I'm just using this Arduino board as a power source, okay? And we just have another one for this input B, and the output of your switch A is being connected to one input, and the another one is being connected to here. So what I mean by that is, under that Lab 10 project folder, I have uploaded this reference so you can take a look. Basically, this is the AND chip, inverter, OR chip, and they all need to be powered and grounded. So this node here should be connected to 5 volt. This should be connected to the ground. And here we have 4 AND gates inside here. So we have the input for the, let's say this is the first one. First one has the input here in number 1 and number 2, and those B2 are being combined to generate an output, and we read that output from node number 3. Okay, so I actually have used this one. So if we go back to the circuit, I have used number 1 and number 2 going in, and this is output number 1. So output number 1 is coming out following this wire, and then that goes through a resistor and an LED, and then that goes to the ground. Okay, so I was just talking about this part. Output goes to green LED and resistor and goes to the ground. Well, it seems like I have mixed up the order, the resistor and the LED, but it actually doesn't really matter. So, and let's take a look at the code. You may still want to keep these structures like void setup, open and close parentheses, void loop, open and close parentheses, and otherwise this guy Arduino won't be able to run because it needs at least something in there. Well, this is like a nothing code, so but we just need this part. So make sure when you're using the Arduino board as your input, you may want to keep this one here as the minimum. And let's see, let's just run. Okay, so start simulation, and now it's running. And if I turn this thing on, okay, my LED is on, indicating, hey, you just turned this switch on. And if I do this switch on again, this turns on, and your output Y gets turned on as well because both of the LEDs are turned on, right? So they get into this logic chip, and then it goes in there. You turn it on, and you can also turn it off. Well, if only one is on, it's not, your output is not true, right? So that you can see here. And one thing to note again is you are not using any of the coding like if, else, like if you read the input and then you do that. We're not using Arduino for coding at all. We are using these logic gate chips to realize this functionality, okay? And that is the beauty of using these digital circuits, because you don't need to code it to realize something. It's once you have these chips there and you just provide 5 volt, then that's it. It can run without any computer like this CPU chip, and no power needed anymore. Just a 5 volt, that's it. So you can put it under the bridge for doing some kind of data processing or whatever, and it's pretty reliable. I hope this helps. That's it for today. If you have any questions, just let me know, and good luck.